All right, so we are still working with that very versatile expression for calculating volume, where we are integrating from A to B some sort of area function. And so if it might be in terms of X, it might be going from C to D and B in terms of Y. Okay, so if it's a dx, then we're revolving. This is for horizontal. Spell today horizontal axes. Really can't spell today, holy cow. And if we're revolving about, if it's a dy problem, then we're revolving about vertical axes. And so today's focus is instead of just a single function that's creating a solid, we've got two functions that's they're creating this enclosed region, and then we're revolving it around an axis or another line parallel to an axis, and it creates this hole that goes through the center. So just like with area, where we said, hey, if we want an area of an enclosed region, we're going to subtract big minus little. It's the same mentality. We're going to take the outside of the function, that revolution, subtract the inside of the function, and we can accomplish that with one integrand. So we're subtracting the volume of an empty space from our solid, so that the cross section now is washer or donut shaped. It's got a hole through the center. Looks like a ring. And then the same old things apply. Be careful about the dx and the dy with your axes of revolutions. Be careful about your radius. Your radius is always measured to that axis of revolution. So if it's off the x and y, then it's just an offset of that much. If it's up there at 4, then it's just 4 minus the function instead of the function itself. And then just some advice. Mistakes usually don't happen in the calculus. They happen in constructing the expressions for the area functions. So that's where you want to get a sketch of the xy plane and get the two functions sketched out so that you know where they're intersecting. So you have the limits of integration and all that stuff. And then I talked about this already, right? When we're rotating about an axis parallel to the coordinate axes, then it's just an offset. So any questions about that? Okay, so how can we extend our knowledge of calculating volume so that we can include non-solid objects? So how can we adapt our knowledge of calculating volume in order to calculate non-solid or objects with holes, non-solid objects? Okay, and I kind of have, they're really similar summaries basically, but the integrand now has the geometry of a washer, right? It's still a pi r squared, but it's a pi big R squared that makes the outside of the shape minus a pi little r squared that makes the inside hole. And like I said, we can accomplish that with a single expression, but it still goes back. We're getting a lot of mileage out of that. Still goes back to that volume expression of integrating an area function. So we've got topic questions today. There's no notes for tomorrow. Yay. Our next quiz is next week. Okay. And then we've got a messy schedule next week because we have no Friday. And so we've got topic questions today, and I'll be around to check your notes. And then we've got 2 cons that are washers.